Good afternoon, 7th graders. This is Mr. Kashi speaking. I would like to go through the lesson for 2.1, which is dealing with exponents and order of operations. The schedule for today's class period, we'll take attendance first. We'll correct or collect the homework depending on which hour you are. Sometimes I'll collect it, sometimes we will correct it right in class. And then we'll go on to notes for 2.1. And the assignment is out of the book today. So those are the 4 things that we have to cover before we leave. Okay. So this is the first page of our notes. I will take you, I'll let you record this down. All right. So our topic for today is exponents and order of operations. Okay, we've done order of operations already this year, but without exponents. Okay, and exponents can get a little tricky. That's why we're taking a whole lesson just on exponents. All right, so just write this 5. How we would say it is 5 to the third equals 125. Right? Exponents in order of operations, 5 to the third equals 125. Then we have to label what these numbers actually are. So this first one, this 5 right here, that number right there, that big number we call the base. That is our base number in an exponential equation. Okay? 5 is our base. And then this little 3 right here, this 3 is what we would call our exponent. And I put them in balloons so you can see that, well, you know, the exponent is actually going to be a little bit higher, what we call a subscript, which goes up there. It's a little smaller, so we know that it's an exponent. Okay, 5 to the third. You know what the equal sign means, so I'm not going to talk about that. But the answer to an exponential problem we call the power. Okay, so 5 is the base, the 3 is the exponent, and the 125, that is what we call the power. 5 to the third equals 125. Those are the 3 things that we need to know when we're talking about an exponent equation. Okay, I have to move on. If you do need more time to copy this down, just have the pause the video here, but I do have to move on for time's sake. The exponent tells us how many times to multiply the base. All right, so if you could record this equation down, record that equation down. 5 to the third equals 5 times 5 times 5. All right, 5 times 5 times 5. Now, in order to do this, some of you might be able to do it in your head. Others, it might be a little more tricky. What I would do is I would start by just multiplying 2 of the 5's together. We know that 5 times 5 is 25. All right, then bring this 5 down. Okay, 25 times 5, the way I think about it is if I had 5 quarters, how much money would I have? Well, I would have $1.25, or in this case, since we're not talking about money, we're just talking about numbers, it would be 125. Once again, this would be the base. This would be the exponent. And this would be the power. Just to review real quick. All right, so 5 to the third, that 3 tells us that we're multiplying 5 3 times, just like that. Once again, if you need to copy this down, have the pause the video. Otherwise, I have to go on just so I get all my video in the time allotted. Next question, how would the following equation look using a base and an exponent? So what we have to know, we have to go from an exponent to a power and vice versa. So we'll be given something like this, 5 to the third, base and an exponent, and then we'll have to come up with the power. All right? But sometimes they're just going to give us 4 or as many numbers as we need to multiply together, and then we have to create the exponent ourselves. Okay? So this right here, 44, the number that is repeated, that is always our base. Okay, so 44 would be our base. And how many times does 44 appear? How many times do we multiply it together? Well, we multiply it 4 times together. Okay, and in this instance, we don't even have to find the power. We just want to rewrite this equation so it looks differently in the form of a base and an exponent. So 44 to the 4th is what we would call that. So the number that gets repeated is our base. How many times it is repeated is our exponent. Once again, if you need to write this down, please have the sub pause the video. But moving on. So if we expand 4 to the 3rd, what would it look like? Okay, so now we're going the opposite way. We're starting with 4 to the 3rd. And then we have to know that it's going to look like the base. The base is going to be what's repeated, 4 times 4 times 4. And the 3 is how many times that we repeat it. So it would be 4 multiplied together 3 times. So whether we're given this and going to an exponent, or given an exponent and then going to the expanded form, the 4 times 4 times 4, you should be able to go back and forth and do either form. Alright, hopefully you got that down. I'm going to move on to the next slide. Okay, if you could copy this table down, I'll give you a little time to do that while I talk here. Alright, there will be a pattern on this table. Okay, so we're doing -2, and then we're raising it to different powers. So it's going to be -2 to the 1st, -2 to the 2nd, -2 to the 3rd, -2 to the 4th, and -2 to the 5th. Okay, and notice that there are parentheses around each of the -2's. That is a point that I will get to on the next slide. So this -1 to the 1st is just what that is, -1. Well, and the 1 up here tells us that we just write it one time. And so -2 to the 1st, well, that's our answer. It's just -2. -2 to the 2nd means that we're going to be writing -2 twice. So it's -2 times -2. Well, we notice that their signs are the same, which means when we multiply two numbers whose signs are the same, it's a positive product. 2 times 2 is 4. Okay, we have a positive product of +4. This next one, -2 to the 3rd, we have to write -2 3 times. Okay, we have to be careful here because we have 3 -2's. We got to do one at a time. So -2 times -2, we learned from our second box here that -2 times -2 is 4. And now we have to multiply that by another -2. Well, now their signs are different. We have a negative here and a positive here. When their signs are different, we know the product will be a negative, so I'm going to write that out right first. And then 2 times 4 is 8, so a 4 times -2 is -8. And then moving on to the next one, -2 to the 4th. So we have to have -2 times -2 times -2 times -2. Well, if we split this up, those negative 2's become a positive 4, and that's because of our second one here. And this becomes a positive 4. These two multiplied together become positive 4. And then once we multiply 4 times 4, we get a positive 16. And then the last one we were multiplying 5 negative 2's together. So I'll just write it real quick. Five negative 2's together. So basically what we're going to be doing is multiplying our 16 by another negative 2. This would give us positive 4. This would give us positive 4. And I'm just going to bring down this negative 2. 4 times negative 2. This 4 times 4 gives us 16. That's where we get our previous box. Well, positive 16 minus a negative 2 will give us a negative 32. Negative 32. All right. Now there is a pattern that you should notice from this table. And now they're increasing, so you multiply by 2 each time. So 2 to 4 to 8 to 16 to 32. But if you can notice, they alternate going from negative to positive. All right. One thing that I would like to point out is that it is the odd exponents that have negative powers. Okay? So that's something to look out for. When you have a negative base and an odd exponent, your power will be negative. That is a rather big note that I would like you to write down. Okay? So I'll write it down right here. Please remember this. This is very important and very easily there's a lot of mistakes that happen with this negative base and odd exponent. So when base is negative and exponent is odd, comma, our power is negative. Okay? So when the base is negative and the exponent is odd, just like it is up in our table, the power is negative. You see how our answers are negative 2, negative 8, negative 32. Right? And that is true for all cases where the base is negative and the exponent is odd. All right? To prove my point a little further, we have these two, negative 2 to the second and negative 2 to the second. What is the difference between these two? Well, just like on our last slide, I'll start on the right here. What this tells us to do is we have negative 2 times negative 2. Our base is negative 2, and it tells us to multiply it twice. Well, they're the same sign. Negative 2 times a negative 2 gives us a positive 4. Over on the left side here, it's a little different. This sign out here, when there is not parentheses around the 2, this sign is telling us that is the opposite. That is the opposite. So, what we have to do is, what is the opposite of 2 squared? Well, we have to do 2 times 2 first. 2 times 2 is 4. What's the opposite of 4? Okay, that's where this comes in. The opposite of 4 is negative 4. These two exponents are not equivalent. This is a positive 4. This is a negative 4. The reason is this symbol out here is opposite, and this symbol right here is negative. They do not mean the same